Okay, a lot of times when there's like two events like this, the easiest way to do it is to make a little chart. So for this one, the number 12, I'm gonna make a little chart. I want that the yellow cube is greater than 5 and the product is greater than 24. Here's what I mean by a chart. So the first one, we have the yellow one. 1, 2, 3, 4, 5, 6. Then we have a blue one. 1, 2, 3, 4, 5, 6. Should have made another row. Okay. This chart represents all the possible outcomes. So, first thing they ask is that the yellow cube is greater than 5. All right. Well, here's all, I'll highlight it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have basically 12 out of, since this is 6 by 6, it's 36. So the first thing we have is the probability that the yellow is greater than 5. Oh wait, actually I didn't even think about this. It says greater than 5, not greater than or equal to. So actually, it's only these ones. So it's 6 out of 6. Or sorry, 6 out of 36, which is 1 out of 6. Okay. And anytime you see the word and, a good rule is you're going to multiply. Okay, so, and the product is greater than 24. So let's think about all the ways that we could get a product that's greater than 24. So maybe I like to just like start in a corner, and this product would be 1 times 6 is 6, and we can just keep going until we get to a bigger number. 2 times 6, that's 12. We're still not to 24. 3 times 6, that's 18. 4 times 6, that's 24. If I went over here, that'd be 20. So that's not big enough. If I went down 1, 5 times 6 is 30. And then 5 times 5 is 25. 5 times 4 is 20. Okay. And then if I went down here, 6 times 6 is 36. And 6 times 5 is 30. 6 times 4 is 24. 6 times 3 is 18. Now, all the numbers to the left of the ones I filled out, those are going to be less than these numbers, right? Because, I mean, like, obviously 5 times 1 is less than 6 times 1. And 3 times 5 is obviously less than 3 times 6. So we don't even need to figure these out. So what we got to do now is figure out how many are greater than 24. And again, not greater than or equal to, just greater than. I'll circle them. 1, 2, 3, 4. Okay. So the probability that the product, I'll do just product for product, is greater than 24 equals 4 out of 36, which is really just 1. Now, usually when you're talking about independent and dependent events and you see the word and, that's a clue that you're going to be multiplying probabilities together. But in this case, when you make a chart, you don't need to worry about that. Because even though this is 1/9 over here, right, because this is 4 out of 36, because there's 4 ways to be greater than 24. And we found out that there's 6 ways out of 36 to be, for the yellow one to be greater than 5. It doesn't matter, because we could just look at our chart and answer the and right now. Where's all the and? Where is it greater than 6 and the product greater than 24? There's only 2 times. So it's 2 out of 36. I don't know if you can see that, I'll do that. 2 out of 36, which is 1 out of 18. So that's where the chart comes in really handy. It makes the math simple. Sometimes you can't make a chart. Like if there's 2 things, like 2 dice, you can make a chart. If there's 3 dice, you'd have to have like a 3-dimensional chart. It gets really complicated. So you'd have to do some math. But A lot of times you can just do a chart. Now, if you were to do this one with the formula, you should see this formula as probability of A times the probability of B, given that A already occurred. That's that formula, okay? In this situation, the probability of A is this one up here, the probability that it's greater than 5, which we know to be 1 out of 6. So I'm just going to write that's 1 out of 6. And then we're going to multiply that by the probability of B, given that A already occurred. Now, we don't know that yet. Okay? Oh my gosh, it's my dog barking. See, we know the probability of just B. We figured that out. Oh, we figured that out right here. Is 1 out of 9, right? Because there was 4 ways. But what's the probability of B given that A already occurred? Well, now there's only these 2 out of 6 ways. 2 out of 6, which is the same thing as 1 out of 3. And if you multiply those together, you get 1 out of 18, which is what we got from our chart earlier, right? And so that's why the chart's really handy. You can just kind of make a chart and figure it out. But this is the formula way of doing it. I don't know if you should probably have seen this notation before. This is the probability for dependent events, meaning you have to adjust your probability for the second event. See, normally it would be 4 out of 36, but it's not really 4 out of 36 because we're saying we only care about the B's when A already happened. So there's only 2 of those out of these 6. So it changes the probability. That's what happens with dependent probability. It changes. And so that's kind of why this product is a dependent situation. Okay, so let's take a look at 13. The blue cube is less than 3, and the product is 8. So now we're going to make a chart again. This is simple. And oh, by the way, the reason why these are dependent, I forgot to answer in the last video because I'd asked you to explain that, is that the product is obviously dependent on both of them, right? It's dependent on both of them. So that's why, because you need to know both. Like obviously, like for example, like if the first one is a 1, if the yellow cube is a 1, well, there's no way to get to a product of 8. So see, that changes your probability. So let's make our chart. Move this down here. And again, we have the yellow one, 1, 2, 3, 4, 5, 6. And we have the blue dice, 1, 2, 3, 4, 5, 6. All right. Okay, the first thing says the blue cube is less than 3. So let's highlight all that. Here's all the times when the blue cube is less than 3, which is a total of 12 out of 36. So we could note that as blue cube, probability that the blue is less than 3. And we just figured out that that's 12 out of 36, which is really 1/3. Okay, and then they also want to know that the product and the product is 8. So this is where we could just kind of go through and find all the things that multiply up to 8. So there's very few things that multiply up to 8, right? It's 2 times 2. I'm sorry, 2 times 4, and that's it. So 2 times 4 here, that one multiplies up to 8. I guess we can just put an 8 there. Or 4 times 2, that makes 8. I don't think there's anything else out here that makes a product of 8. Right, like that's a 6. 3 can't go into 8. 4 makes an 8. 5 can't go into 8. 6. So there's just really these 2. So the probability that the product equals 8 is 2 out of 36, or we could say 1 out of 18. However, we don't really, when we're dealing with dependent probability, you have to first like acknowledge what the first probability is. I think you've probably seen, maybe you've seen this notation, or maybe you see this in your notes, something like this. Actually, that might be off the screen. Let me come down here. Probability of A times the probability of B given that A already occurred. So you do normally multiply, and this is why the chart's so helpful, because this answer I'll show you in a second. Maybe you've already figured out what the answer is. But you have this probability of A, right? So the A in this situation would be the blue cube is less than 3. And then you have to multiply that the probability of B, given that A has already occurred. So, like in this situation, the probability of B would normally be 1 out of 18. But what's the probability of B given that A has already occurred? Well, now it's just this 1 out of these 12, right? So this we already got the first part, so now it's just 1 out of 12. So the formula here should be that we could take our probability A, which is probability the blue is less than 3, and say that's 1/3, and multiply by the probability of B, given that A already occurred. So that's not this. This is just probability of B normally. So the probability of B, given that A already occurred, it looks like there's 1 out of 12 ways for that to happen. So we can say that's actually 1 out of 12, multiply those together, and you get 1 out of 36. And that's the correct answer, because look, there was only one space, maybe do a different color, one space where the blue was less than 3, and the product was 8. Yeah, there's another time when the product is 8, but that doesn't, that's not, doesn't consider the event A already happening. So maybe the chart helps you figure out the answer. This is the formula way to do it. I hope that helps you figure that out. This one should be a little bit easier to figure out. I'll do like one with you, and I think you could figure the rest out. The reason why this is dependent, by the way, is because we have the number of people that immigrated like from Cuba in 1990, okay? Or from Cuba in 1995, or from Cuba in 2000. So this one says, like part A says, that a selected person is from Cuba, given that the person immigrated in 1990. See, the probability changes depending on the year. That's why we would say it's dependent. It's not the same probability regardless. So given that it's 1990, this is the number. Given that it's 1995, this is the number. Given that it's 2000, this is the number. So probability A that a selected person is from Cuba, given that the person immigrated in 1990. So we'd have 10,645. Probability that Cuba, given that we're talking about 1990, that's 10,645 out of, remember, probability is always, you always want to have your total on top, or your total successes on top, which in this case is 10,645, and on the bottom you have your total successes and failures. So these would be failures in this situation, meaning that they did not come from Cuba. So we're going to do divided by 10,645 plus 4,466 plus 1,886. Forgive my bad handwriting here. That's how you would figure that out. You're going to do something very similar for B and C. So the only, like B is very, very similar. It's just Spain in 2000. And then this one is that it's 1995, given the person was Ghana. So here you're only looking at this one, and you're comparing it to all these different years. Okay, have fun.